How can artificial intelligence transform goal setting from abstract wishes into concrete action plans? Let's explore the science. Traditional goal setting fails 70% of the time. I can change this by converting abstract intentions into structured implementation plans. Let's start with the fundamental problem. Why do most goals fail? Research shows a massive gap between intention and action. Studies indicate that 70% of goals fail due to this implementation gap. Goal adherence decays exponentially. After 10 weeks, only 30% of people maintain their original commitment. So what causes this catastrophic failure rate? Let's examine the cognitive mechanisms. 4 failure modes dominate. Goals remain vague, lack environmental cues, have no execution plan, and face unplanned obstacles. Now let's explore implementation intentions, developed by psychologist Peter Gollwitzer in the 1990s. Implementation intentions follow a simple structure. If situation X occurs, then I will perform behavior Y. This creates an automatic trigger. Research shows implementation intentions increase success probability to 91% when the cue is encountered. Implementation intentions create neural pre-wiring. The brain links situational cues directly to behavioral responses, bypassing conscious deliberation. Let's compare an abstract goal with an implementation intention to see the difference. Top, abstract goal lacking specificity. Bottom, implementation intention with precise temporal cue and concrete behavioral metric. Artificial intelligence can systematically generate and optimize implementation intentions at scale. AI pipeline, parse natural language goal, generate candidate implementation intentions, optimize for specificity and feasibility. AI evaluates multiple constraints: temporal feasibility, resource availability, energy levels, competing commitments, and historical success patterns. Optimization score S equals weighted sum of feasibility functions, FI, for N constraints. How does AI identify the optimal trigger points for maximum compliance? AI analyzes circadian energy patterns, identifying peak performance windows at 7 a.m., noon, and 7 p.m. for different task types. Now let's examine the Premortem technique, a powerful obstacle anticipation method. The Premortem inverts traditional planning. Instead of asking how to succeed, we ask, assume we failed, what went wrong? This mirrors mission rehearsal in aerospace engineering, where teams simulate all possible failure modes before launch. Each potential failure mode is identified, analyzed, and mitigation strategies are developed before execution begins. System reliability R equals 1 minus the product of individual failure probabilities, PI. AI excels at Premortem analysis by processing vast datasets of historical failures. AI analyzes millions of similar goal attempts, extracting common failure patterns and generating ranked obstacle predictions. Let's walk through a concrete example of AI Premortem analysis for a writing goal. AI identifies top 5 obstacles with historical occurrence probabilities: fatigue, interruptions, unclear starts, perfectionism, and distractions. How do we systematically convert these predicted obstacles into actionable countermeasures? AI creates implementation intentions specifically designed to counteract each predicted obstacle. Let's design specific countermeasures for each identified obstacle. Each obstacle receives a specific if-then countermeasure that can be executed automatically when the obstacle is detected. Probability of success increases from 30% baseline to 82% with implementation intentions and premortems combined. Let's develop a quantitative framework to estimate the impact of this approach. Assume we start with a standard goal having the typical 30% success rate. Visual representation shows only 30% success for baseline abstract goal setting. Baseline probability equals 0.30. Research shows implementation intentions provide approximately a 2.5 times multiplier on success rates. Probability with implementation equals 0.30 times 2.5, giving 0.75. Premortem planning adds another 1.4 times multiplier by preventing unforeseen failures. Total probability approaches 1.0, though we cap it at practical maximum of 0.9. Comparative visualization shows dramatic improvement from 30% baseline to 82% with full AI optimization. Success isn't static. Let's model how goal adherence changes over time. Red curve shows standard exponential decay with half-life of 4 weeks. Green curve shows AI optimized decay with half-life of 20 weeks. Adherence at time t equals initial adherence times e to the negative lambda t, where lambda is the decay constant. Standard lambda equals 0.15 per week, while AI optimized lambda equals 0.03 per week. What is the cumulative impact over 1 year? Let's calculate total productive days. We integrate adherence function from 0 to 52 weeks to find total productive time. Standard approach yields approximately 6.7 equivalent weeks of productive work. AI optimized approach yields 33.3 equivalent weeks, a 5 times improvement. AI doesn't just set plans once. It creates an adaptive feedback loop for continuous refinement. The system operates in continuous cycles. Plan, implementation intentions, execute, measure outcomes, adapt based on data, then replan. AI continuously analyzes which environmental triggers lead to successful execution and which result in failures. Success rate improves linearly with iteration as AI learns optimal parameters for this specific individual and goal. Success at iteration n equals initial success plus learning rate alpha times iteration number. Real life involves multiple, simultaneous goals competing for limited resources like time and energy. AI allocates resources across multiple goals, ensuring that each receives sufficient time, energy, and attention to meet their specific requirements. How does AI balance competing goals to maximize overall success? AI uses optimization techniques like linear programming to allocate resources efficiently across goals, considering constraints and priorities. The objective is to maximize the weighted sum of goal achievements, where Wi is the weight of goal I and Xi is the achievement level. The constraint is that the sum of all goal achievements cannot exceed the total available resources. By solving this optimization problem, AI can find the optimal allocation of resources across goals, maximizing overall success.